OK, hey, everybody. Thanks for coming. We're going to talk about Angular Elements. The talk title that's on your agenda is definitely not stolen from the Hunger Games, so just ignore kind of the talk title. It's about this, so we're going to talk about Elements today. My name's Rob Wormald. I'm a software engineer on the Angular team at Google, of all places. I also started the NGRX project, which is a kind of Redux-style state management system for Angular. And I'm also Angular's rep in terms of web standards, so kind of upcoming web standards. I'm Angular's representative in these meetings, talking about new standards, things like that. So we're going to kind of do this in two stages. I want to talk about what Angular is doing today, kind of some new stuff we've got coming out in our new release, and then talk a little bit about the future. So we just shipped Angular 6.0. Last week we shipped that. It came out a little bit late. We wanted to make sure it was nice and polished for people. There's a ton of really cool features in here. Things like easier upgrades. We've done a bunch of work to make Angular 6 even smoother than the previous release. And this is kind of the way that we position the talk that I'm going to do here. So at this point, Angular's gone through kind of 5 major version iterations. And we're pretty happy with where it's at for building kind of big single-page applications. All of our documentation, all of our tooling is kind of built around this concept of building SPAs. I got a really cool tweet the other day that the Windows Admin Center is actually an AngularJS, or it's an Angular application. So it's kind of served from the MSI. So this kind of thing we're really good at. But Angular can be a little bit more challenging to use in scenarios that don't fit this kind of single-page application model, right? And this is really because we built it for single-page applications. This is where we get paid at Google to build, SPAs. But part of my job is talking to developers, talking to teams who are using Angular, and we get all kinds of feature requests, use cases that people are doing with Angular that maybe don't fit that SPA model. So the one we get all the time is this kind of, I've got existing HTML, I've got a server-side rendered app, and I kind of want to enhance it with Angular. AngularJS, the old version of Angular, was really good at this. But in Angular, we kind of took some of that functionality away. We did it for a good reason, but it didn't take away the use cases that people had for this kind of stuff. So this is like the most requested feature request that I get on Angular right now is, I already have an app, I already have HTML, I already have some server-side rendered thing, I want to put Angular into it. You can do it, but it's hard. It's not easy to do. Things like CMSs kind of fall in this similar kind of example, right, where you have some system where you've got content in databases, you've got kind of non-developers writing HTML. They might be composing HTML pages. And really, they may not be framework developers. They may not be JavaScript developers. So CMS is another case we hear a lot about. And then things like widgets, right? I want to build like a little calendar widget. Or we've been talking to the Microsoft SharePoint framework team, right? And these are kind of little mini apps, little mini widgets. Again, Angular can do this today, but it takes a lot of Angular-specific knowledge. It's not easy to consume these things. So widgets are another case that come up kind of all the time. And this is the big one, this sort of mixed environment, right? So when the first version of Angular came out almost 9 years ago, we were one of very few JavaScript frameworks out there, right? Most people picked Angular or Backbone or Knockout, something like this. And nowadays, there are a lot more, right? There are a huge amount of new frameworks in the ecosystem. We've got AngularJS, of course, is still around. Things like Polymer and Preact and React. You might just still be using jQuery. You might be just using vanilla JavaScript. And so we talked to a lot of teams who are doing this, right? They have a lot of different technologies, and they want to stop basically rewriting the same date picker every time they change frameworks. And we have this problem at Google, right? Google has sort of half a dozen internal frameworks. We've got Angular and AngularJS, Polymer, which you know about, Angular Dart, which you may not know about, Wiz, which you definitely don't know about. Wiz is what Gmail is made with Docs is made out of Wiz. So we have a bunch of internal teams who, again, have the same problem the outside world does, right? They're rebuilding stuff. They're doing a lot of duplicate work. They're not able to share code between these different frameworks. And so we end up building the same thing again and again and again. So we wanted to see if we could maybe do better. And for the past year or so, I've been leading this project we call Angular Elements. And the idea is we really want to open up Angular to a whole bunch of different use cases. We really want to make it more approachable for people who may not be developers, may not be hardcore JavaScript developers. And we're doing that by kind of connecting up with web standards, right? I work at Google. The Chrome team is just across the way from us. They've done a lot of work on things like web components. And we want to see if we can maybe make Angular a little more flexible. So web components is really the kind of core of this idea. Raise your hand in the room if you've ever used or ever heard of web components. Let's start with that. That's maybe half of you. Raise your hand if you've ever written a web component. That's like 5 of you, maybe, right? So not many, right? But they're out there. They've been around for sort of 5 years or so. If you don't know what a web component is, They're a set of API standards that allow you to create custom reusable HTML tags. So that thing, the button, the span, the div that you know, web components are designed to let you create your own versions of these. And importantly, they can be used with any JavaScript framework library that speaks HTML. Angular speaks HTML, React speaks HTML, Preact speaks HTML, and anything that's a custom element should just work in these environments. And part of this web component spec is this core custom elements API. I like to joke that there's actually no such thing as a web component. It's kind of an idea, and really what we're talking about are these low-level APIs like custom elements. So if you've never created a custom element before, they're really, really simple to do. You start with a basic ES6 class. You extend from the HTML element. You could extend from the HTML input element or from a button element, whatever. But it's just a simple ES6 class. And then you register it with a browser, and you tell it, when I put hello-world as a tag on the page, go ahead and start up this class for me. So this is the lowest level API. It's really, really simple. They have lifecycle hooks, so you can get a callback when this thing is inserted into the DOM. You can get a callback when this thing is removed from the DOM. This connected, disconnected tells us that. You can also tell I care about attributes on this HTML. So when the name attribute changes, I also get a callback that says, this has changed. Get me the old value, the new value. You can have property setters. That means you can actually just say this element.name, give it a value. So this is how pretty much every DOM element in the browser already works, right? Inputs have attributes. They have, you can set the type. You can set the placeholder. You can get a hold of them programmatically. You can set properties on them. So the cool thing about custom elements is really they allow you to do exactly what the browser does to kind of extend the native functionality of the browser. This is a very, very powerful, powerful thing. They also do event handlers, right? So you can spit out native events. So I can add an event listener to this and then listen to them. So you can dispatch the same sort of events the browser does. So the question becomes well, if you've got all this in the browser, if you've got this API, why do we need frameworks at all, right? Why isn't everybody just building everything like this all the time? And the answer is really that there's a lot of other stuff that comes with building of applications, right? So Angular is this platform. We have a bunch of stuff. We have things like a really great forms API, routing, HTTP, I18N, all these things that are really hard to do yourself. This is why people use frameworks, right? And web components, custom elements, don't really change that idea. They're not competing with each other. It's just kind of a new facility we can add to the browser. Cool. So this idea of Angular elements is really taking the power of Angular, Angular components, Angular templating, all these things, if you're an Angular developer, you know how to use already, and kind of merging them, gluing them together with custom elements so that we can maybe get the best of both worlds. So this is a standard Angular component. A laser pointer, cool. It's got a selector at the top, right? You've got a template. It's got some data binding there. We've got an ng model. We've got an event handler. And then we're telling, basically, from the outside world, give us the input of the name. This is how we emit an event to the outside world and say the name has changed. We can set up an event handler here so that when we click the change name here, we're going to fire this and then kind of emit an event to the outside world. So this is a completely standard Angular component. Typically, you'd register that in ng module, right? So we've got browser module. This is our dependencies. This is the Angular renderer. This is kind of all the machinery that Angular needs. And we just kind of create a module, a little baby app, if you like, and we say, cool, we're going to declare that we own this hello world component. We also want to make it available as an entry component. Don't worry too much about that. And basically, what we're going to say is, cool, we're going to take this sort of baby application, and we want to kind of make it available outside of Angular. So this is how you'd bootstrap an Angular app today. You'd bring in our platform, you'd bring in the module, and you basically kind of spool up this platform, go ahead and bootstrap it, and that starts your application up. The same thing works in AOT mode and ahead of time compiled mode, right? You have a module, you compile it, you start it up, and the application kind of starts up. So with Elements, we wanted to see if we could make this kind of same thing that you're doing every day as an Angular developer available to people who are not necessarily Angular developers, right? So we've added a new API in Angular 6. It's this Angular Elements package. It's got a single exported thing. This creates custom elements. And basically what we're saying is instead of kind of automatically bootstrapping this application, this component we've just created, what we're actually going to do is not bootstrap the application, not bootstrap the component, I apologize, but we're going to register it with the browser. We're going to tell the browser, here is this kind of this element that we're creating, and I want to register it using that custom elements API. So the new Angular API, how to create custom element, returns us that ES6 class I showed you in the first couple of slides. And then we just tell the browser, hey, this hello world element that Angular has minted for us, go ahead and register it with the browser using this standard API. And now it's just a hello world element, and I can do whatever I want with it. There's a little bit of a shorter hand to do it. Again, this is not a thing you need to worry about if you're not kind of deep into Angular. There's a shorter hand way to do it. But basically, we're doing the same thing. We're getting a hold of our component. We're getting a hold of an injector. And we're just registering our kind of generated class with the browser. So again, we can do this in AOT mode. Pretty straightforward thing. And then all I have to do to use it is just put it on the page, right? I don't have to kind of say, like I do in Angular or React or Preact or Vue or the applications, kind of connect this class to this DOM element. I've already done that using the browser APIs. So literally all I have to do is put it on the page. I can set an attribute on it. That name attribute there will get linked up with the name input that I put on the components. And now it's just a standard DOM element. So anybody who does HTML or JavaScript at all already knows how to use it, right? So I can just say basically document create element. This is a completely standard browser API. It gives me back an instance of this hello world component, and then I can just append it to the document, right? Just document.append child. I can set a property on it, and that will basically, when I set that property, Angular is listening for that. It will go ahead and update the internals of the component for me. I can do the same thing with attributes, right? So again, totally standard DOM API. This is the kind of programmatic equivalent of in the HTML saying name is equal to whatever. We can add event listeners, right? So again, totally standard browser API. You're going to hear me probably say that a dozen more times. It's important. This is just a totally standard DOM API. Adding an event listener for a named event, and then we do whatever we want when that event comes out. We can also, this is a new API in the new version of custom elements. We can programmatically create these things. So I can say to the custom elements API, give me back that constructor that I gave you. I can do this at any point in the application. It gives me back the actual constructor. I can just create a new instance of it there. And then again, it works like any other DOM element. I can append it. I can add event listeners to it or whatever. So it's pretty standard, pretty simple stuff. If you're an Angular developer, what we're really saying here is this thing you already know, the host element, the kind of element that your Angular component is bootstrapped to, that's what an Angular element is, right? We're kind of just making this a first-class citizen. So for example, I can inject my element ref here. This is my host element. And now I can, from the inside of my Angular component, which you'll notice does not extend from the HTML element, does not extend from a base class. It's just a vanilla JavaScript class. And our custom element is sort of wrapping it, right? It's just a wrapper around this Angular element. This has some nice benefits, because it means we don't have to worry about, for example, using this thing on the server, where HTML element might not be available. Makes it a lot more flexible, makes it really easy to test. But if we want to, we can get a hold of the actual DOM element just by injecting it there. We can set up listeners, right? So if I want to have this set up with a button, for example, I can say, listen to click events on the kind of host button there. That's what a host listener is doing. And then do something instead of my component. I can do the inverse. So if I have some property on my component, I can say, go ahead and reflect that back to the DOM element. So we're basically keeping this kind of internal isActive Boolean in sync with the actual DOM attribute. So again, if you're an Angular developer, this is really all we're doing is just gluing together kind of two concepts you know how to use already. Dependency injection. This is a big reason that lots of people use Angular. This has been kind of one of the biggest reasons we think that custom elements web components have not really gone mainstream, because you can't use things like DI in general. We did a lot of work. We wanted to make sure that all of the kind of facilities of Angular were available for developers to use. So DI still works exactly as you expect it to. In Angular, we kind of have this injector hierarchy. So we've got a platform injector, and that holds things like the renderer and the HTML sanitizer. These are the kind of platform level. And then each individual module, each individual kind of Angular application, it might have things like services, right? You might have a storage service. You might have something that's kind of talking to a remote API. And then every component has its own injector as well, so you get this kind of nice hierarchy of things. Angular Elements works exactly the same way. Instead of having a component injector, we have an element injector, but it means that things that you provide to the module, things that you provide to the platform, things that you provide to your application can be injected into these elements. So it gives you, again, kind of the best of both worlds, right? It works like a standard DOM element, but you get all the power of Angular inside of it, which is pretty cool. You have a little more programmatic control here, and just to show you what we're doing. So we're creating that platform, that's that top-level injector. We're then bootstrapping our module, which gives us kind of our module-level injector. I like to think about module and kind of app as a similar concept, right? A component is just a UI thing. An app might have more things than just components. So bootstrapping that module gives us an injector, right? And then we're just going to tell Angular when we create this custom element, go ahead and stick the injector from the parent into my custom element. So this makes anything that's available at the module level available across all of my custom elements, which is cool. And then again, I just kind of register it with the browser. Browser is normal. So just to go back to this again, right, once this thing is registered, it is just a standard DOM element. There is no other code than this to get this thing started up. I could put 2 of them on the page. I'd get 2 instances of it, set the attributes, set the properties. It's just standard HTML. Again, same thing, standard JavaScript APIs, creating elements. One trick, though, if I wanted to inject a different injector, if I wanted to, for some special use case, and I'm doing this in the SharePoint integration I'm writing at the moment, if I wanted to give like a different injector to every single element, if I do it this way, I don't have any place to kind of pass in arguments, right? The browser API doesn't understand dependency injection, doesn't know anything about that. So I can't use this document.createElement API. What I can do is go to this brand new API that basically gives me back the constructor, and then I can create an instance of it. But what I can actually do is just pass in a different injector, right? And this gives us really the kind of flexibility that we need at the lowest levels. So for most cases, you'll be able to just do the kind of create element thing. You may never even call this, right? If you're using ASP.NET to render stuff from the server, you'll never have to call this. All you've got to do is stamp out the HTML, send it to the browser, and these things will start up. But in the DI case where you want to do something advanced, you always get a hold of the constructor and just go ahead and inject the injector that you want, and everything kind of works as normal. Content projection, raise your hand if you know what the word transclusion means. 3 of you, you're AngularJS developers for sure. So content projection or transclusion is the idea that I have an HTML element, right? And what I'm going to say is, this is the template, and then I'm going to put a space on the screen that basically says, I want to project some content from the outside world, and I want you to put it in this area in my template. This works exactly as you'd expect it to. So I have my hello world element. I put an ng content thing in the template of this element. And then I can just put content in between the two element tags here, and Angular will go ahead and take that content and project it into that slot in the template that I gave it. This is flexible, and this is really powerful for composing UIs. Again, if you're building a CMS, people who are not Angular developers, who may not be JavaScript developers, don't have to think about this. They just lay out the HTML as they expect it to, and Angular just kind of handles it. There we go. So that's like the net output looks like this, right? We start with this. We have a template that looks like this. And the final result in the browser, right, we've got our kind of internal template, and then the stuff we put in the outside world has been projected into that slot in the template. I put an asterisk here. This works, but it's not dynamic, right? Because Angular is only able to know ahead of time what you expect to give it. So part of the Web Components API is this new idea of slots. Slots are effectively the native version of transclusion. And slots and Shadow DOM work exactly as you'd expect them to in Angular Elements. So we can do the exact same thing, right? We've got a template again. This time we're going to use the native slot API and say, when I give you content from the outside world, go ahead and stick it in this kind of space in the template. We turn on view encapsulation native. This has been baked into Angular for a couple of years. This is the native Shadow DOM API. And it just works as you expect it to. So again, we have a kind of internal template. We've got a slot, some part of the display where we want stuff to end up. We actually use the element in the DOM like this. That content that we're projecting into the inside, it will get inserted into that space on the slot. You can also have named slots. So you're able to say, basically, I have sort of a main area. I might have a header area. And then from the outside world, I can say, go ahead and put this span into that slot and put this header into my header area of my template. So it's a very powerful way to do composition at runtime, again, with no code. Any kind of server-side rendering framework can spit out the HTML in the structure you expect it, and then the browser kind of wires that all up when everything boots up. Pretty slick. So we'll jump into a quick demo of this, just to kind of show you that I'm not making all this up. So if you've not used this before, this is Stackblitz. Stackblitz is built on top of the Monaco editor, the thing that builds up in VS Code. Working with a team who runs Stackblitz, it's got TypeScript integration. It's a really, really powerful kind of web editing setup. I'm actually in a browser here, which is pretty cool. And then I've got my kind of Hello World element running in this other tab. So we'll just jump in real quick. I'll give you a quick tour around the code. Everybody see that? Yeah. So I've got an app component. It's very simple. It's got a template, right? It's just got a p tag and hello and a little bit of text interpolation. As I've written my component here, I'm again saying this is the selector for it. Here's the template. If I've got styles, and I'll show you the styles here. I'm able to do things like go ahead and say style the host. This is the host syntax from the Shadow DOM. Go ahead and apply these styles to the Angular element itself. Style the p tag this way. So again, very, very simple element here. And I've got this input, which is basically saying to Angular, I'm going to pass you values in from the outside world, right? And if you're in an Angular application, you just pass these through in your template. This is how you pass data down through different components. We just hijack this basically for Angular elements, and we just kind of wire these things up. So if I go to my app module, this is where I've got, again, my dependencies from the outside world coming in. I've got my browser import. So this has got things like the renderer, all that stuff that's important to making Angular work. I've got my actual declared component. And then inside of this app module, and so this is like my kind of baby app, if you like, I'm just injecting the injector and keeping a reference to it. And then I'm going ahead and, again, calling that new create custom element API, passing it the app component, passing it an injector. There's a couple more options you can pass in. They're not really important at the moment. I get back this, which is just an, again, it's an ES6 class. It extends as ng element constructor, which under the hood extends HTML element. So the thing I'm getting back here is, again, just a standard ES6 class extended from HTML element, and then I register it with this browser API. This is the custom elements API. It's built into any modern browser that supports custom elements. So this is up and running now. I can jump over to my other tab here. Cool. So it's very simple. Not a whole lot going on inside of this element here. But what's cool is I can actually jump in here, and unlike every Angular application, basically unlike any JavaScript framework that's out there, I can just go into my DevTools and I can mess with this thing. So I can go in here, I can edit, and I can say, hello, build 2018. And it will sync that up. I didn't do any code changes here. I didn't change anything in the JavaScript world. I literally just went into DevTools and modified it. I can do the same thing. So I can get in here, and I can say, go ahead and give me an element. Say document.create elements. I think I called that my app. Wasn't you paying attention? My app. If I could spell my app, that would be even better. Great. So I get an L back. If I kind of log this out, you'll see it's just a standard DOM element, right? And then I can say document.body .append child my L, and it's on the page. And then again, I just go and mess with it here. Go put an attribute in that says name Rob. Great, so that reflects through. I can query for that, so I can say document.query selector. Oops. Give me my dash app. Assign that to a variable. Again, I've got a hold of that thing. This is the first one, and I can say a.name is build 27/2018 exclamation point. And again, that will reflect in. I can say, great, a.set attributes. Set the name, build, and that should work exactly the same way. So again, what I want to get across here is that internal to this component, it's an Angular element. You know, we've got templating going on, we've got host listeners and host bindings, and all this Angular machinery going on internal to the component. But as the consumer of the component, you have absolutely no idea it's an Angular component. You don't have to think about it. So any designer, any developer, in any environment, it can just drop this thing into the page, work with it, and it kind of works exactly as you'd expect it to, which we think is pretty cool. Back to my slides here. Cool, so let's just go back to these use cases real quick. So this big one is enhancing existing Angular applications. One of the things on the Angular team is we really do try to dog food these things before we ship them to the outside world. We have all kinds of kind of good ideas, all kinds of crazy ideas, all kinds of bad ideas, and we try to make sure that they're actually validated inside of Google on a Google project before we ship them to the outside world. So for us, really the biggest application we maintain as the Angular team is our website, angular.io. Angular.io is an Angular application, as you'd expect it to be. It wouldn't be very good PR if we weren't using our own framework for our own website. But it's different, because unlike many kind of interactive Angular applications, where there might be many components with many forms and lots of stuff going on, the Angular website is mostly static HTML. Most of the documentation is written as HTML or Markdown on disk in our GitHub repo. And then we kind of run a bunch of build tooling, but we spit out standard HTML because it doesn't make sense for us to turn a bunch of static HTML into components, right? You're wasting really a whole bunch of cycles there, a whole bunch of energy, a whole bunch of time. It's not the right model for static HTML to be made out of pure components, whatever the framework really. But we do have a bunch of interactivity in these pages, right? If you scroll through our documentation, you go through one of the guides, as you kind of scroll through these pages, you'll see these islands of interactive kind of functionality, right? So this is a code snippet here, and we're doing kind of styling here. So the developer who's writing this documentation doesn't really do anything other than write the code, and then our component that wraps this, so this kind of blue box on the screen here, where did my laser pointer go? This blue box is an Angular component, and it's doing content projection, as I just showed you, and it's kind of enhancing that with this styling. Another example there, so like this is a tabs thing, right? We've got a couple different tabs. You can flip through the code. So this is interactive stuff, but it's like 2 or 3% of the application, right? It's not the 97% static HTML. It's all over these pages. Here's another one. This is the kind of API listing in Angular. This has got search, interactivity, a whole bunch of different stuff. And historically, we have had a bunch of really, really gnarly code inside of the Angular.io repo to wire these things up. And effectively, what we had to do was basically every time we changed the HTML page, we had to go query that piece of HTML, find all the elements that we cared about, right, and kind of manually do this really gross bootstrapping process where we said to Angular, look, I've got some kind of widget on the screen here. Take this Angular class, connect it, bootstrap it into the component, go ahead and pick up all that HTML that I've projected in and kind of wire that up. And it's really not very nice. I used to have the code up here, but it was too gross, so I removed it. When we shipped the first version of Angular Elements, it took us something like 2 hours to port all that stuff over because most of the work was literally just deleting a bunch of code. So this was kind of validating for us that this worked. So you could actually go to the Angular.io website right now, all that stuff that I was doing where I was getting a hold of the thing and document.creating elements, and you could do that today. Angular.io is now shipping with custom elements. It's the first thing we've shipped that uses them, so we're pretty excited about that. The other thing that we talk about a lot, and I don't really have a good demo of this, but this is what we were talking to the SharePoint team about, is this idea of using an element, using a web component, as like a packaging format, right? So you might want to write a really rich interactive application, but you're going to embed it into SharePoint FX, into an NG upgrade application. Again, maybe you want to have a bunch of different teams writing a bunch of different kind of widget functionality. They might be connected to a backend. They might be using functions, whatever. And you want to assemble them into applications kind of at runtime based on metadata, whatever you want to do. We kind of call this the container case, and this is the thing that we're also really wanted to make sure that worked pretty seamlessly. We are ready to go on that today. You could start using this for SharePoint. I'm actually going to be at the SharePoint conference in a couple of weeks talking about this. So we're pretty excited about kind of the new world that this opens up for people writing Angular apps. This third one is one that's really close to my heart. So raise your hand in this room if you've ever written a date picker. Bunch of people. Raise your hand if you enjoyed writing that date picker. Nobody, literally nobody in the room, right? But we do this all the time. If you go to NPM and you search date picker, there are something like 750 date pickers on NPM, right? And that's because everybody rebuilds them because I'm using React and my colleagues are using Angular and somebody else is using Vue. And because they're not really compatible with each other, we end up rewriting the code. We end up redoing the work again and again and again. And obviously, we think that this is not ideal. As much as we'd like everybody to use Angular for everything, we know that that's not really feasible in the modern age, right? So maybe it would be better if we were play a little more nicely with others. And so this reusable widget case is kind of what we're going to be tackling for the next 6 months. Really, you could do this today with Angular Elements as we've shipped it in 6.0. The main problem is code size here. The main problem is that basically, because we're shipping kind of Angular, which is this big project with a lot of stuff, it may not make sense for a date picker quite yet because you don't want to have to ship 50K of code for a single date picker, right? Just a quick note on production readiness and kind of support here. So all the big browsers except Edge so far have kind of said we're on the custom elements train. Edge seems to be positive about this. There's a user voice issue that you can go upvote if you think this is a cool thing. The good news is that there are polyfills maintained all the way back to IE9. I put the asterisk there just in case. You can do it in IE9. It gets a little more slow, a little less performant, but the polyfills exist, so you can do it if you need to. Obviously, this gets better on modern browsers. The faster, the newer the browser is, the less polyfills you ship, kind of the smaller and better everything is. So what about tomorrow? We think this is really cool stuff. Again, we're using it on our website already. We're talking to a bunch of teams internal to Google who are using kind of the early APIs of Angular Elements already. So we're pretty excited about where we are today, that it's usable, it's functional, there's a lot of really good use cases for it. But One of the other efforts we've got going on, so there are kind of two main things happening in the Angular team at the moment. The first is this Elements API we just shipped. And the other is this project we're calling Ivy. And Ivy is basically a code name for our new rendering engine. We've changed the rendering engine in Angular a couple times already. If you've been an Angular developer for a couple of years, you may have noticed that when you went from version 2 to version 4 and you recompiled your application, everything just got much smaller for free. This is a big part of the Angular story. We're evolving the framework kind of under the hood, but we want you to be sure that you can just continue to write and not have to change your code every week. So Ivy is the next generation of our rendering engine. My director, Brad Green, a year ago or so at our last big conference, kind of put out this target to our team and basically said, look, we're today at 36K. This is compressed, right? It's kind of uncompressed. It's something like 150, 170K. This is where we are today. We want to get down to a level where basically we're under 10K so that people can basically use Angular without thinking about this at all. So he promised he'd bake us a cake. This is why we call it the cake threshold. This is how he gets us to do anything on the Angular team. He just bakes baked goods, and we go, OK, that'll work. So we're pretty excited that at our last conference a couple of weeks ago, we introduced the first kind of demos of Ivy. Ivy's this rendering engine. You can see this is the kind of code size now for a Hello World Angular application with Ivy. This is all in. There are no dependencies. There's nothing else on the page. Literally, you have an Angular application doing Hello World in just under 3K. So this is cool, right? So what we're going to be doing between V6 and V7 is really integrating these two ideas. We have Angular Elements, which is useful today, kind of using, if you like, the kind of slightly older version of Angular. And then we have this new Ivy project that's being developed kind of in parallel. So what we're thinking is rather than all of that code that I was doing on previous pages where I was bootstrapping and creating modules and all that stuff, we want to just be able to basically say, when you create an Angular component, just make this thing into a custom element for me. We'll pass it through the compiler and kind of do all the hard work for you. Don't worry too much about this, but this will basically, when we take that decorator that you do here, we down-level it to a custom element definition. So now you've got your Angular component that's got its Angular element def kind of connected to it, so you can just work with it. I've got a demo of this just to show you real quick. So I don't have this one running on StackBlitz because this is a little bit more experimental. So I'm in the Angular kind of main repo here. I've got a very simple to-do demo app that I'm working on here. Pull this up. Great. So standard Angular stuff, right? We've got a basic kind of to-do interface here. We've got a service, which is our to-do store. It's got some data in it, things like filtering and removing and adding, all the stuff you do in a standard kind of Angular service. Below that, I've got a kind of basic standard Angular component. It's got templating. This is kind of using all of the features of Angular. It's got ngIfs and ngFors, ngRepeats, and all that stuff that we like about Angular. Pay no attention to this kind of mess in the middle here. This is us still working out compiled APIs. This is ngFor, ngIf. These are just directives you know how to use. And then I have a very simple call at the bottom here, which is just defining that to-do app that we created as a custom element, right? So same kind of idea. I think I have this actually running up here somewhere. I do, maybe I do. Cool. So this is not actually running on the server. Let me boot up my server here. So we're using Bazel to build this. If you've not heard of Bazel, this is the tool that we use inside of Google to build everything. All of our development work works with Bazel. This is what we use. It gives a really nice turnaround time. But you as an Angular developer could use this in Webpack and Angular CLI, all this, the tooling, you know how it works already. Go back over here. Get up and running. Cool. So this is now to-do MVC application. It works. We're demonstrating Ivy Elements now, so I'll check that off the list. Great. And if we go into our DevTools here, I'm going to actually drag this thing up the screen. There we go. I'll refresh that. You see we've got some CSS, but the actual bundle for this application is 12K minified, no dependencies. Where did my network tab go? There we go. So you can see it's 12.2K. This is for a component, three components, a service, CSS, all that stuff is baked in, and it comes in under 12K. This is the level where you don't have to think about it anymore. You can put this on a page. It's smaller than every framework that exists. It's smaller than most jQuery widgets at this point, right? At this point, this is a very, very micro piece of code. And we think this is going to open up a really interesting world, because at this point, you could build a date picker this way, and at 10, 12K, 5K, who cares, right? You can ship it out, put it on NPM, people can consume it. And importantly, again, you see that I'm not like loading Angular in here. I don't have a bunch of Angular script tags coming off of NPM. The entire application and all of the bits and pieces this thing needs from Angular are bundled in that package, and that's it. So it makes it very portable. The only thing you have to do to consume this thing is if you look at the index.html, you literally have that one bundle. I've got my little elements wrapper running at the top. And this is all you would need to do. You don't need to get on Webpack. You don't need to do a build tool. You don't need to do anything other than just put the script tag onto the page. This is important because, again, what you want is people who are writing JavaScript applications, web applications, however they're doing it, to be able to consume the stuff you're building with Angular, but not have to know anything about how Angular works. So we think this is pretty important. Cool, so I just want to show this slide off again because I like really showing that number there a lot. This is like an order of magnitude smaller than anything we've ever built with Angular before. And we think we actually have some headroom. Before I got on the flight to come out here yesterday, Mishko, our team lead, pinged me and he said, hey, I've got that number under 1,000 bytes. And I was like, wow, OK. So we're really close. We expect Ivy to be basically out in V7 of Angular, which is now about 5 months away. Before we ship it to the outside world, of course, we will make sure that we can run it inside of Google without breaking the world. The goal of the Ivy project, importantly, is everybody who is writing Angular applications today. You've got thousands of lines of code, and obviously we do not want to make you rewrite that code ever again. So Ivy will be completely backwards compatible. Literally, it would just be a compiler flag you flip, recompile your application, and you should see fairly significant savings in your code size. So I like to say this is really just the beginning, right? This is a brand new project for us. We've been working on it kind of 6 months to a year or so. But we think this is really the beginning of something really, really interesting, not just for Angular, but for the web as a whole. We'd really like everybody to get out of their kind of tiny silos that we all work in and begin to share code. We're working quite closely with the Ionic team. I don't know if you know them. They built this really, really amazing, it was actually built on top of Angular, and they moved everything over to web components, which is great because it works for everybody. But of course, because Angular already supports web components, everything Ionic and Stencil build just work right back into Angular. Svelte is written by the guy who writes Rollup. The Polymer team have obviously at Google been doing this for quite a long time and have been telling us for years, hey, you should just build stuff this way. And I think everybody's kind of beginning to realize maybe that's not such a terrible idea. Skate.js, which is in the bottom there, they are a project which is basically wrapping all the frameworks who aren't doing things like Angular elements. So Skate provides wrappers for Preact and React and all the different frameworks. And I'm super excited that we get to add Angular to this list today. Cool, so that's everything from me. I'm quite happy to take questions, comments, concerns about this. Like I said, this is kind of really new for us. We expect over the next 6 months to have even more coming out. And if this is something you try out, we'd love to get your feedback. We'd love to hear from you. We'd love to hear if you've got a use case that maybe we haven't thought about, something that you think, oh, maybe this will work in my world. I'd love to chat with you about that. So come and see me whenever. Thanks for listening.